Alright folks, thanks for coming. In this video we'll continue where we stopped today where we stopped on the previous video. On this video we're gonna concentrate on slope. We're gonna deal with a bunch of slope problems. In other words, what I'm gonna do is if you're given a graph and 2 points, you should be able to find the slope of that graph, okay? And then what we're gonna do after that, we're also gonna do, if you're given an equation, a linear equation in 2 variables, you should be able to find the slope by writing the equation in what they call slope intercept form. So let's deal with those 2 problems in this video. We'll seek for slopes, and what I'm gonna do, I'm gonna use the 7 problems I used in the other video, the video I just did today. Go check that video out. I'm gonna use all the problems. I think there are 7 of them. I'm gonna start with them. Now, but I need to recap. Okay, I'm gonna recap on the mathematical definition of a slope. Okay, remember what I said? Slope of a line, right? Slope of a line with 2 variables, right? Slope of we can also say the same thing as slope of an equation with 2 variables. Is represented as rise over run, okay? And then we say also that represents change in y over change in x, okay? Change in y over change in x. And then I told you can write that as change in y can be represented as y2 minus y1, okay, over x2 minus x1. Where basically this is where this is where x1 y1 or that pair right there, and x2 y2 are 2 points, okay? Where they are, these are 2 points. 2 points on the line, okay? On the line. That means the line passes through them, right? That's what that means. And then notice that also x1 cannot be equal to x2. That condition makes sense, because if x1 is equal to x2, then you'll be dividing with 0, which is impossible, okay? So these are the stuff you need to keep in mind. And then I show you that the way you look at x1 and x2, right? x1 and x2, let's say you have a x1 here and then x2 somewhere. Let me draw this more. x2 here. This is x-axis, this is y-axis, okay? And then the same thing with y1, y2. So the change, you're going from y1 to y2, you're going from x1 to x2. So the change there is you take x1 and subtract from x2. The change there is x2 minus x1. Because you have to see, if you understand the Cartesian coordinate, that should make sense to you, because this x2 by definition has to be larger than x1. The same thing in the y-axis. The change in between y2 and y1 is y2 minus y1, okay? Because by definition, y2 must be larger than y1, okay? If you understand, the way the the Cartesian coordinate system works. So if you think about that carefully, you will understand what I'm saying. So basically we're gonna solve a bunch of problems now, okay? And we're gonna solve the problems, the one we did before, 7 of them. We're gonna go to the graph. Each graph is we're gonna be given 2 points. 2 points like it say here 2 points on the graph, and then we're gonna find the slope using those 2 points. Okay, that's what we're gonna do next. All right, see our first example there. We'll have 2 points there. Based on what we learned so far, obviously that's a negative slope. But we'll have to prove that by solving the problem, right? The thing we need to do with all this example is we take those 2 points and we'll find out the slope. We're just looking for the slope using the 2 points. All the examples I'm gonna show you now, that's the same thing we're gonna do, okay? These are the same example I used in the previous video, and I'm gonna possibly use the same example in the next video, because I want to use all of them to show exactly how these concepts work. All right. Okay. As we said, slope, which is m, slope is equals to m, is rise over run, right? That's what we are agreeing on. That's the definition of slope, right? Okay. Okay, how do we determine run? How do we determine rise? Let me make this comment. Every time we're gonna count, see the units. The units are marked off by 1, 2, 3 on the x-axis, and 1, 2, 1, 2, 3 on the y-axis, okay? So every time, this is x-axis, this is y-axis here, okay? Every time you count, this is based on the concept we learned from the Cartesian coordinate. Every time you come to the left, especially when you're dealing with rise and run, if you're counting towards the left, that means negative, okay? When you're counting, if you're heading towards the left, that's negative. If you're heading towards the right, that's positive. I'm talking about when you're counting. I will show you in a minute. When you're counting up, that's positive. When you're counting down, that's negative, okay? So we'll show you that in a minute. Now, we can use this point here, this one here. We use this point here. And then we draw, let me see. Let me change the ink. We'll draw, we're gonna meet, let me see, meet over here. We'll draw this like this, and we'll go like that to determine the slope. Okay? So we're starting from this point. Alright, so if we count, we'll count the rise, right? Don't forget, going up is the rise, going horizontal is the run. To count the rise, we'll start from this point here. Start from the point 0 with all that pace 0 and -5, okay? We'll count 1, 2, 3, 4, 5, 6, 7, 8. We counted 8 and we were going up, okay? So then the rise is 8. And now notice something. We're gonna count the I'm sorry, this is the rise. The rise is 8. We're gonna count the run. because we started from this point here, 0, -5, and we're counting up. Then we'll have to count left. We'll count left. We'll count 1, 2, 3, 4. You see that? So it will be -4 because we're counting left. Make sure you understand that. So when you do that, the slope will be 4 divided 8 is 2. It will be -2. Okay? That's how you find that. In fact, we can, let me change my ink. We can use this point here. We can use -4 and other pair -4 and 3. And then we'll count from there, right? So let's do that. We're gonna come up with the same result. Okay, so we'll count we'll start there, then we'll count the run first. The run is 1, 2, 3, 4. I'm counting the blocks. That's 4, +4, okay? It's +4. Okay? And then from there you have to continue. From there then you count the rise. Now you go in the negative direction because you're going down. 1, 2, 3, 4, 5, 6, 7, 8. You see that? So it's -8. So we get the same result, -2. You see that, right? Okay, that's one way of doing it. We can also use the point directly. Remember the definition, rise over run is the same thing, slope is the same thing as changing y over changing x, right? So that would be y2 minus y1 over x2 minus x1, right? So I'm just gonna do this to verify, to show you that we did it right. And then you choose the point you want to start with. That's all. Let's start with this point as the starting point. Okay, then we'll say this is x1 and this is y1, and we'll say this is x2. I'm talking about this -4 is x2, 3 is y2. Okay. Alright, so if you do it like that and you put all the point in that equation, what do you get? You do that, what do you get? You get, let me see, y2 is 3 minus y1 is -5, okay, over x2 is -4 minus x1 is 0, right there. See that, right? So you simplify that. Plot on the numerator, minus, then in bracket another. It's like over here it's really -1 times -5. So it will give you 3 plus +5, okay? And then the denominator will be -4. So if you simplify that, you get 8 over -4. And then if you cross things out, you get -2. So the slope again is -2. That's what we got before. You see that, right? That's what we got using all this method here. So that's how you do it, okay? Methodically. And then you pay attention, you come up with the right answer. It's not a rocket science. You just have to pay attention to what you're doing. So, okay. So let's move on to the next example. Okay. So the next example, you see the 2 points there. Again, we say slope is equals to rise over run, okay? And then we can start with any point, let's start with this one here, other pair 8 and -2. We'll start with that. So what we need to do, it doesn't really matter how you draw the stuff. You can draw it on the right hand side or you can draw it on the left. It doesn't matter as long as you're consistent with when you count. You know, if you're moving left, it's negative. If you're moving down, it's negative. If you're moving up, it's positive. You're moving right, it's positive, okay? So, let's draw. We can use this thing here. Let's use that. Let me see. They will meet right here. We can do it this side. We'll draw that. That's rise. And then this is run, you see? Yeah, this concept is very, very important. When we go to calculus, you will see. Okay, so this is this run and rise, okay? All right. Now we'll start from this right here, and then we'll count. See, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. See, we counted negative direction. So we'll say that's actually the run. We'll say the run is negative 14, okay? And then, now when you stop there, you go up. You continue up. So that would be positive direction. You go 1, 2, 3, 4, 5, 6, 7. So it will be positive direction. You get 7, okay? Alright. So you simplify that. That would be, the whole thing will be minus 1 over, let me see, 1 over 2. See? I know we're correct because if you look at the graph, is slanting. If you look from left to right, it's slanting downwards. So it has to have a negative slope. Alright? But let's use our formula too. We use our formula that says m is equals to y2 minus y1 over x2 minus x1, okay? Now we'll start with this point here. We'll call this one x1, y1. And here is x2, y2, okay? And then we'll put the points in the equation. What do we get? We'll get 5 minus 2, okay? Over minus 6 minus 8. So you simplify again. The numerator is like, it's minus 1 times minus 2. That will be positive. So what you have there is 5 plus 2 over so you subtract 2. The 2 negative will still be negative. So that there should be 14, negative 14, okay? You simplify, that will be 7 over negative 14. We'll get the same thing, negative 1 over 2, see? You see, so the slope will use 2 methods, we got the same thing, okay? So that's how you do it. Very simple. You just pay attention, like I said before. Follow all the rules, keep going, you'll get it right. Okay, here is an example for, we're looking for the slope. They give you 2 points on that line, and you're looking for the slope, okay? You don't even have to know the equation of the line. All you need is 2 points. You need 2 points, and then you can find the slope. I mean, if you eyeball the problem right there, from what was discussed before, the slope is negative. Because if you go from left to right, see how it's slanted downwards. So we know it's going to be negative. So the slope is m is equals to rise over run. Okay? Alright. So we can use this point here. It doesn't matter. We can draw from here. We can draw from left or we can draw from right. It doesn't matter. But I choose to draw from the right side right here. I could have chosen to draw this line from the left side, but we'll do this now, and then you go like that. You see where they meet right there. So the idea is to start counting from this point. You start counting. So this is rise and this is run, okay? So the rise you count first. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice that we are counting upward, so the direction is positive. So it's positive 10. Now we'll do the run 1. So you continue going the same direction, okay? So 1, 2, 3, 4. Okay, so it's a negative direction, so it's negative 4. You simplify, that would be, let me say, 5 over negative 2, right? Because 2 divided 10 is 5, 2 divided 4 is 2. So slope is negative 5 over 2. That's the slope. Alright? That's what you get now. You know. That's what you get there, okay? Okay, let's, we can also use the other method that says slope is equals to change in y over change in x, which is y2 minus y1 over x2 minus x1, okay? So if you do that, what you get is, well, first you choose your point, label them. This point here, we choose this one as x1, y1, okay? And then this is x2, y2. Okay, so we'll plug it in. We'll have 5 minus 5, okay, over 0 minus 4. Okay, we'll simplify. Again, it's like minus 1 times 5. So it's 5 plus 5 over minus 4. What do you get? 10 over minus 4. You simplify. It will be minus 5 over 2, like we got before, you see? So this m, using that method and m using the other method is the same. Alright? So we'll move on. We're gonna move on to this one. Alright, we're given 2 points and we need to use them to find the slope of that line. Okay, so we continue the way we've been doing it. M, the slope is equals to rise over run, right? Okay, so we can start with this point. If you add body stuff, the slope gonna be positive. It's from the left to right, you see it's steep up. So, but we do what we normally do. We gotta finish the calculation. So if we join these right here, like that, and then you go, let me see what's wrong with this thing. You go like that. You join the 2 points, right? Okay. So we can start here. Don't forget this is the rise and this is the run, okay? We'll count the rise first. We're going to go up. Start from this point, go up in positive direction. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the rise is 10. Okay. And then we'll continue in the same direction, okay? The run is gonna be also positive because we'll continue, we're going rightward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's gonna be 15. So the slope is equals to divide by 5, divide by 5. Divide by 5, you get 2. Divide by 5, you get 3. The slope is gonna be 2 over 3. Okay, positive 2 over 3. Alright. So we can use our formula, the other formula, to find the slope. The other formula is slope is equals to y2 minus y1 over x2 minus x1, okay? And then we'll label the points. This is x1 and this is y1. Okay, this is x2, this is y2. Alright, so we'll put the point into the equation. We get 6 minus 4 over 9 minus 6. Okay, so the both of them have the same. It's like there's one here, negative times the negative, so it will be the same thing as 6 plus 4, the same thing in the denominator, 9 plus 6. Okay, so you simplify that, you get 10 over, what is that thing there? 10 over 15, something we got before. Divide by 5, what do you get? You get 2 over 3. See, it's the same thing. That's the same thing we got before. See? Very simple, man. Alright, look at this example. It's a vertical line. Remember we said when we did introductory video that a vertical line has a slope that is not defined. In other words, the slope of a vertical line is undefined, but you're going to find out why. You know, so we'll look for slope of this line using what we know, okay? We'll say, we'll say M is equals to rise over run, okay? Alright. Now, we don't really have rise over run, you know, because there's not, how do you connect the 2 points like we normally do? See the problem? So then we're gonna use the other equation. The other equation, see, because you see in this one we'll have, actually we'll have you know, between these 2 points we'll have rise, but we'll not have run. Run is 0. That's what we can say, but and then you can't divide with 0, right? Because run is 0. But let's do it with the other formula. It's a y2 minus y1 over x2 minus x1, okay? And then we use the two points given. Notice that okay, notice that this, if we choose it as x1 y1 x2 y2, notice that the value of x is the same thing, you know, but that's okay. We'll put it in the equation. We'll solve. We'll get 5 minus 3, okay, over 4 minus, you see where the problem is, 4 minus 4, see that? So if you simplify that, you get in it's actually 8, because it's 5 plus 3. Let me do it properly. 5 plus 3, okay, over 4 minus 4, the same thing as 8 divided by 0. You can divide by 0. You cannot divide by 0. So if divide by 0 is undefined. Undefined, right? Every time you divide by 0, you can't. So it says the slope is undefined, you see? That's how they got that, because it will end up, when you have a vertical line, you end up dividing by 0. Okay? So that's why it's good to know how to use the same the two methods. You use this or you use that. That way, if one doesn't work or if you're not sure, then you can use the other one. Okay, if you're not sure of the result you got, because in this case we can say y is the run is equals to 0, but how do we say that, so that's why we have to use the other formula. Now let's do the last one. See, this is the last one here. This is number 7. You see what is going on there? It has 2 points. This is again it's a horizontal line. A horizontal line, remember we said the slope is 0, but we just have to prove it here. Again, I don't see how you can do run over, remember slope is rise over run. That one would not be useful in solving this one, because then you only have one direction. You only have run, but you got no rise. So you can say rise is 0, then whatever you put on that run, the whole thing will be 0. But to prove this, we just use our formula, okay? It's equals to y2 minus y1 over x2 minus x1. Okay, let's use this as x1 and y1, x2, y2, okay? And then we'll put in the equation, we'll get 5 minus 5 over x2 is 5 minus 8, okay? So you simplify, you get 0 over what? 0 over, let's see, over 13, right? Yeah, 0 over 13. It doesn't matter what you have on denominator, the whole thing will be 0. So slope is 0. That's how you do that, man. Alright, subscribe to my channel, share and like this video. If you have any question, leave it under the video and then I will answer as soon as I can, okay? Alright, thanks for coming. Bye.